that input block back. Try F, capital and lowercase. No.
Sorry?
It should be a directory called M.
Where would you put that?
Right there. It's either capital F or lowercase m.
No.
No.
Yep. I was going to say, I don't think it got installed because I tried to find it. Because I would imagine that it would have been in the past and I could have just typed. You know,
Yeah, there's a lot of stuff outside of that because they don't populate the.
Okay.
We'll fix that.
Fair enough. But, yes.
So, I think we remember playing around with ANTRAC. It uses a different convention in reading scans than an icon or voxel does, in that it describes, let's say, voxel describes lesion as a 0, the lack of material, and to describe that as a 1.
Mm-hmm.
And that there's some conversion that needs to take place.
Yes. And that...
Not gone into that yet?
No. Usually, for the most part, that turns out to be the output where we quantize the values to make sure that it's 1s or 0s. But yeah, usually at the end. Now, and that's a step that we'll come to.
That doesn't matter for 3+.
No, as far as I've known, it hasn't affected any of the lesions that I've fed to the script. The next part here, this 0 flag, basically, is the output prefix that we're going to be using. The next one, the -t flag, we now use for the symmetric normalization transformation, and this flag effectively tells ants to perform the diffeomorphic warp. There's currently within our script, I think this value is set to 0.25. I think is the current value, and I think that's hard-coded into the script itself, right? But presumably,
You can pass out a whole different transformation to include that family.
okay, can you? All right.
That's the default.
All right, so that's the default. But by changing and increasing this, it does. So it can improve your warp because it changes the search space that it's going to basically use before it moves on to the next iteration. So it basically it applies to these numbers here, like how long it takes before it now moves to the next iteration. Oops. And the last parameter that I have here is the Gaussian regularizer, and that just basically imposes a Gaussian constraint on the warp's deformation field. So if you think of it as like Saran wrap, right? And you're going to sort of punch through and stretch the Saran wrap. This value is basically imposing certain weights on how far you can stretch and shear and that element of the warp. Okay. The second command in warp, so after you've gone ahead and ran the ant command, the next thing is the image, the warp image transform. And again, this now applies it to the actual, the first one calculated the parameters. The next, this command is actually going to apply it to the actual files itself, right? And again, it uses some of the same flags and notations. 3 just describes, that it's a 3-dimensional file. Usually start off with the file to warp. The second value here is the output name that you wish to name your files. R is the reference image. Again, that tends to be the fixed image that you started off with from the ants value. It's going to also output some affine parameters. The next value that it outputs is the next value that it's taking in is the deformation parameters, and that was calculated by ants. So when when you ran the previous program, and actually can show you some of that values here. It produced a series of files where it gave you the parameters to go for your inverse warp as well as your forward warp. And so essentially when you're running this ANS command, when you're applying the second value here, you're basically telling it to use these parameters, whether it's going to be the forward warp or the inverse. You can change it at that point. And the last one is the mask and lesion file itself. And essentially, that's the basic elements of the script that it's, or the basic elements of the command that it's using. So as we kind of mentioned before, Dan has a script. It's called ants.sh. And it essentially makes putting in all of these parameters a lot easier, so you don't necessarily have to remember everything. You can leave some of the default values, which we've gone through, and we've determined what are the best possible parameters. And the basic elements of that script that it's going to take in are, what is your structural file, what is your mask, and what is the prefix that you wish to output, the prefix of the output files. And the -x file, the -x flag uses N3 to normalize the file itself. I'm trying to think of how I want to describe this. There we go. Sorry, blanking on the exact terminology here, and I'll show why that's important a little bit later. But it also should be important to note that the warp can take 1 to 2 hours depending on how you've changed your parameters or what different sets you're using. As far as another important thing to keep in mind is that the script makes these steps a little bit easier, and that is what we're actually doing is taking the subject and we're warping to a template, and then we're warping that template to column. So basically we're using an intermediate template to go from subject space to column space.
And that's the same one that whole thing you talked about
yes.
last time, right? Yeah. Okay. So it's actually, right, isn't that the same one? So it's, I don't know about it, but I mean it was a mix. It's a, didn't you say it's actually got some TBI brains in there, and right? It's made up of TBI and control. So I mean, just in case anybody
I'm actually not on the trail of a better intermediate template for the stroke group. I'm trying to find some old templates that apply that.
Good.
Yeah. I think our last iteration had some issues with the current template. So, and if you're not here at Penn, right? I mean, it does within the ANTS. I think help menu. It actually tells you how to create your own intermediate template.
ANTS actually comes with a template construction script that automates the whole process.
There you go.
I have never used the intermediate template before. It looks like because directly warping subject brain to column is the distance between the two brains are too large. So
yeah.
It looks like you are dividing the set into two.
Yes.
Using a kind of intermediate
yes.
template.
And we find that we get.
Do you find it kind of usually successful in that way? So you get much less number of failures.
Yeah.
It's not so much the difference between the subject brains and column, like in terms of shape, but in terms of signal properties, because we're
what property? I'm sorry.
Signal properties. So we're getting these nice scans off of this nice fancy Trio scanner, and column frame is from like a 1.5D scanner 10 years ago or so. So somebody took a bunch of scans that are from our nice scanner, and carefully, laboriously using landmarks and whatever other tricks they could have to calculate a nice mapping to the intermediate template. So it's more because of that than because of the brain shape.
I see. So you are not normalizing everybody's brain to the intermediate template. Oh, so from the individual subject, so working from individual subject brain to the template happens just once between individual subject and template, and then from then on you just use to work between template and intermediate template and calling brain. So you do, like, for example, statistics on intermediate template, and then just work the result.
No.
The idea is that there's two transformations here, from subject to intermediate template and intermediate template to column. The second one is the really hard one. It's the one that's hard to get exactly right. So that one, somebody did. Actually, we didn't even do that one ourselves, and I'm trying to get an even better one now. That one somebody did once because it's hard. Whereas from subject to the intermediate template is easy. But we still transform everything all the way to column. So when we do this, what my ants.sh script does is it works each subject to the intermediate template, and then uses the existing transformation that somebody laboriously calculated
to go the final step.
Transformation all the way to column.
Right.
But we still do all the analysis in column stage, and I stage.
And that still requires a transformation of each of those, right?
Yes. So essentially, you can think of it as it's going to run at this ant script twice, right?
No. That script does it twice. That command.
This command twice is essentially, you can think of it as, one way to think of it, it's not actually doing that, because we can go straight, but you can think of it as it's running this command twice. Once to get from the patient to the template and outputting those parameters, and then a second time to get from the patient to the...
Is there advantage in doing it that way, instead of, running statistics and everything on intermediate template? I don't want to nitpick
It hardly matters at all because it's the same transformation applied. Once you get the intermediate template, then the same transformation is applied to everyone. You're not really losing any more data from doing true transformations than one because the transformations are what's the word? They're composited. So it's really only one example. So it doesn't much matter.
Yeah.
Oh, sorry, I'm a little bit lost. How are you create the intermediate template from each template?
So we didn't actually create ours. As Dan said, someone else went ahead and created the current template, intermediate template. But within ANTS, there is a program that will allow you to compile a series of other scans and create your own intermediate template.
And from what you said, Dan, it sounds like the crucial reason that you would want to create your own individual template really has to do with the
spatial property.
Yes.
Yeah, it has a lot to do with the signal intensity associated with the difference between this scan and what we get from our scanner.
You can work subjects directly to column, and it works okay most of the time. It's just a little bit better if you
use this intermediate. And I think it's safe to say that when we do have scans that do have distortion, this especially helps out to deal with that level of distortion.
If the scans that we have are from 3T or from 1.5 or 3T?
No. I will say that we've used the same template, and I will say that this template has also worked for clinical scans that we've gotten from other scanners.
There's another thing that you can kind of see in these scan scopes, which I'm not 100% sure if this is true, but depending on what coil you use in the scanner,
yes,
you can get a different kind of inhomogeneity problem.
Exactly, and that's why we use, as we talked about, we use the X flag to deal with it. And I will, next slide, I believe, brings this into, is a great example of the inhomogeneity that you can get from. So this is actually from our scanner. If you notice that, you know, there's